Alrighty, I think we're up. So yeah, so we should talk about that article you wrote recently, which I read last month, and then I kind of forgot about it. I was going to read it right before, and I guess you read it again, right?
Yeah, 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 I did. And I'm not sure what to say about it. I like the article. I like the ideas in it.
So
Uh,
what prompted you to write that?
well, there's really what prompted me was poking through Quora and seeing Alan Kay saying something which a totally fit something I've been thinking for a number of years. I
Hmm.
mean, this idea that we keep on inventing new programming languages and new tools, and it's just all on the virtualized versions of punch cards.
Yep, yep.
Um, and why haven't we done anything better? Better? Why haven't we done anything better since then?
So what do you
And
mean
I
by
think that's really.
virtualized punch? What do you mean by what are not virtualized punch cards? I guess like what's outside the scope of that?
Oh, okay. Well, I'm older than most people, and I'm older than most people think I am. So,
So you look good for
uh,
your age.
so yeah, I started college in '73, and at Cornell, when you were taking your intro to programming for engineers, you went to this big room that had these punch card machines, and you typed physical cards that were 80 characters long,
Hmm.
and that had your program on them. One card for each line of the program, and if it was a really big program, then that was like a whole box of cards.
Yeah, yeah.
Uh, and towards the end of my time, I had a summer internship at Bell Labs where I was actually doing data science, to
Hmm.
tell you the truth. Uh, but they gave me a big box of punch cards, which was data from a study that they wanted me to analyze. So I had to haul this box of punch cards down to a big room in the basement where they had an IBM 370 and a punch card reader. And I had to write my program on punch cards because that was the only way to talk to that machine. So punch cards were these physical things, roughly, I don't know, 8 inches wide, 10 inches wide, and each one recorded one line of code. Uh, and it was basically, well, if you made a typo, you had to throw the punch card out and replace it with a new one.
Yeah, but at least there's
If you,
only one line, I guess. Yes, that's one saving grace that you're just fixing one line as long as it's
yeah,
local.
but if you dropped them, then you were in big
Right.
trouble,
Right. So you randomized your file. It's the equivalent of, randomizing the lines in your shuffling the lines in your file.
Yeah. So, um, but yeah, we're still thinking in that, I mean, most programming is today is still done in that, 80 line, maybe 80 character, maybe
Hmm.
120 character, fixed with font mode. And I don't know what better would be. I've seen a number of things that I would like to think were better, but aren't really, at
Yeah.
least to me.
It's funny that you mentioned your Bell Labs experience because I'm just now reading Brian Kernighan's Unix memoir book. I think he self published that. I sent the link to you.
Oh yeah,
He
yeah.
just like self published this small book. It's great. I mean, it's just like this oral history talking to the folks at Bell Labs in the '70s, and it was such a what I found interesting about that was just it's such. I mean, these stories have been told. Xerox PARC Bell Labs been told numerous times, but I loved how it was such a software centric view of basically like the developers of these early Unix systems. They were dog fooding. They were talking to colleagues down the hall. It's like, oh, you made a program to do this, and then I'm the user, and then I want to invent pipes because I need to pipe into some other thing. We're doing a document processor. We're using, a grammar generator, and it was just such a generative time. Of course, it was still virtualized punch cards then, but it was just such a, and I think Alan Kay with his latest projects have tried to replicate that sort of environment where this sort of environment seems necessary for making the next big advance. And I think it dovetails with some of the themes that we're probably going to talk about this hour. How do we invent what environment do we set up to invent that future that you would want, hopefully?
Well, that is an interesting question. Although what came to my mind just then was this group of people who were talking to each other, going down the hall and saying, hey, I did something, I did this. And it's sort of like, the vision Stallman had of free software. It's like, how do we keep that freeness and that sense of collaboration from collapsing under industrial pressure?
Yeah.
And that's a different bunch of questions.
Right.
Pretty sure that Stallman would clearly put us plainly in the Emacs Forever camp,
right.
which frankly is my own when I actually do programming. But
so your ecosystem, you are in that Emacs ecosystem, and you've been in that for.
I've been in that. I've been in that since the early '80s.
So I guess given that, can you imagine a better environment just given that constraint, right? I mean, not that you have to be constrained by Emacs, but can we imagine taking an Emacs, or nowadays it's like Visual Studio Code, right? It's basically there's an all-inclusive text processing and programming and plugin environment. Would it take something really different, or could we actually maybe achieve that with extensions to our current IDEs? I don't know.
Well, from the extension, there's two things there. One is, can we do something really different, which would be fun to brainstorm on. But from the standpoint of extensions, I mentioned in my email this morning that I saw. Just this morning, I saw a post about a thing called RapidQL, which I'd never seen
I'll
before.
Pull that up. Yeah.
Yeah, that's worth looking at, because based on 15 minutes reading a blog post summary is that it does well. They show it working in they show it working in VS Code. I understand it can also work in other things, but basically what it does is gives you a uniform interface to pretty much anything, any web service that is any web service that's what is it now my
it's exposed certain endpoints, right? But yeah, I think the general problem, just to summarize, I'll put the link to all these articles, is that, there's this plethora of APIs out there, and everyone requires some one-off hacks, right? Everyone requires some sample code and some authentication tokens or whatever. And modern web apps, or any apps, right, are just really, I think you mentioned this in your article. A lot of modern apps are really just plumbing, right? They're chaining together different really powerful APIs and services. And in fact, even our computing environments are APIs, right? You're provisioning some Amazon servers or some, Kubernetes or Docker things. You can imagine all your DevOps stuff as just API calls. So in a way, we've kind of, I don't know if it's a different kind of dream, but we've achieved this interesting goal of programmatically controlling everything, right? Even our hardware, right? Even our virtual hardware, right? So you can imagine writing code to provision entire apps. Of course, you have all the issues that come with code, but it's an interesting future we're in. That it may not be the original, Alan Kay type utopian future, but it is some kind of future. I feel like we've made some significant progress in this realm. It just is really complicated, though.
Yeah, and that struck me as being, exactly what RapidQL is. It's a tool for plumbing together plumbing together other web APIs.
Yeah.
And in particular, one that I'm sure you have done a lot more of this than me. But the first big painful thing you have to do with any new web API is figure out how to log in reliably and make the thing work. And granted, I was only looking at a short video example that was probably done by one of the authors, so of course it worked.
Yeah.
But this appeared to be just okay. Here's an API that serves weather in different cities. We'll just access it, and we'll take care of all that credential management for you, and that in itself would be a huge help. That parsing the results, which pretty much with SOAP or now I'm forgetting all my modern names. So, yeah, with pretty much any modern API, that's reasonable. That's reasonably standardized. So yeah, a lot of the what uh, yeah what I think it's getting you to is a model of programming that really is about the plumbing rather than about all the gyrations you do to make the plumbing work.
Yeah, yeah. I mean, that's the hope. I mean, it's funny. I don't want to go too off a tangent, but I have all these YouTube videos on my YouTube channel, and I really wanted to programmatically just edit the descriptions. Like I just wanted to change some links, and I just went yesterday. I just manually clicked through hundreds of videos and just edited the descriptions. And there is an API to do that, right? There's a data API, but to my knowledge, I was trying to go through the contortions. To my knowledge, if you're just a regular YouTube user, this is just me investigating. You can't actually access the data mutation APIs unless you authorize your app. Like you have to get Google to approve you somehow, because the idea for security is that anyone can make these apps that can just, if you send someone a link to your app, they can log in with their Google account and it gives them access to their YouTube data, right? So the only way to do it poking around is that you need to be like a Google Suite user, like a paid G Suite, an organizational member, right? So that if you have an organization, then within your org, you can let anyone access it because it's supposed to be trusted, right? If you're just deploying inside your org, they have to trust you. But I have just a free YouTube or Gmail account, so I don't have that option available. So even something as simple as I just want to change my own YouTube data, my impression is I don't think there's a way to do it programmatically unless you go through the whole approval process and such. So that's the sort of, frictions that I face nowadays because, it just, I guess they weren't meant for that personal use case, right? It just was not meant for you to use it yourself. It's meant for, the API is meant for anyone to access and log into. Therefore, they need all this heightened security around it and such. So that's what reminded me of when I saw this Graph API thing.
Yeah. Well, I mean, that's interesting from the standpoint that they really probably do need that security around it, because if they let anybody go in there and edit it, then anybody would go in and edit it.
That's right. I Google scales. I mean, this is another issue of, we can talk about end user programming and kind of this long tail program, is that if you're using Google's APIs or YouTube's or Facebook's or Twitter or whatever, they have to be so braced for production scale, right? So both the scale has to be production, also security, right? Because they have to account for all these cases where I think they trade off, obviously, security and reliability and scale for convenience, right? Like, really, I conceptually just want to do something simple. I want to use my own YouTube login. I have my own password or whatever, or API key, and I just want to write a Python script to just go in all my videos and just edit description. But that's not really feasible because the way their APIs are set up is for kind of production. Their APIs are set up for someone to make a YouTube plugin or whatever that needs all the security and authentication and such. So, it's just that our API providers are often, except for these hobbyists, right? Our production quality API providers, I'm sure Amazon is something similar, right? To provision all the servers and stuff. It's not really meant for kind of a end user kind of a hobbyist sort of use case, in my impression.
I'm a little bit curious. How would the API itself be? I mean, I'm asking that because before, iTunes insisted on wanting everything to be in the cloud, which I actually still resist. I mean, all my iTunes, all my music I keep locally.
And you do your own backups. You can control your own backups that way.
Yeah, I can control my own app backups, and by the way, I can also play it when I'm on a flight.
Right.
But they have an API, which I don't know, might be more usable if you're programming in Objective-C or one of the languages they like. I was doing it in Ruby, and it was really fairly unfriendly API. Not that difficult once you figured it out, but a lot of it
was the Ruby thing a third party thing on top of it?
It wasn't a third party thing. It was an open source thing that was coming out of Apple, but they weren't.
Oh, interesting. It wasn't their main thing, probably, right? Presumably.
No, it wasn't their main thing. Yeah, and the guy who wrote it, I knew, and I mean, a year later, he was working for some other company.
Right.
So, you know how these things go.
Yeah, I mean, this is the other. I mean, there are a few people in software engineering and HCI research who look in this. I mean, Brad Meyer's group has had decades of work, and they've had a bunch of work around API usability, right? So they do these empirical studies of like, getting developers to assess how quote unquote usable these APIs are. So it's kind of like APIs as user interfaces, right? And there's some other people in the academic community who kind of do these sorts of heuristic evaluations of, all the stuff that you can imagine evaluating GUIs, right? Like, is the interface consistent? Is it discoverable? Do the same things appear in the same places? You can imagine running these analyses on APIs and say, are the nouns and verbs consistently named, right? Is there some surprise cliff because of, backward compatibility, right? Backward compatibility is how these APIs build so much cruft in them, right? Like different versions and stuff. So
yeah, I'm trying to think. I mean, one other area that comes to mind that's actually, I think in some major ways going in the wrong direction is, say, web programming. And this is a conversation I've been trying to have lately. If you start with basic HTML and CSS and very simple JavaScript, you have something where, we didn't have the kind of graphical tools that I'm envisioning and that I think Alan Kay was envisioning. Well, actually, we sort of did at the time. But you had something where you could actually learn to program by going view source, cutting and pasting a whole bunch of stuff, and it worked. And a few years ago, things were getting worse and worse from that standpoint, and then everything suddenly became reactive.
Yeah.
And part of me says that, from the standpoint of like the democratization of, I don't even want to call it programming at this level. The democratization of being productive, creative web users.
Yeah.
That's a huge step in the wrong direction.
Yeah, totally. I mean, this is a really great topic, actually. It ties back to the same YouTube example from last night. So basically, my example is I have hundreds of videos. I have like 750 videos. Not all of them are public. Some of them are unlisted and on playlists. And I had to go through, linearly go through all of them, click on, there's a bunch, there's a big menu, and then I click on each one, it pops up the description. I basically just edit out some lines. I needed to update something. And obviously the best way is if you could do programmatic, but we already talked about how the API didn't work. So the second best way is I wanted to be able to, write some script, right? Maybe some jQuery thing I run in the console, or some, grease monkey thing or something. And then I try to view source, and I try to like reverse engineer how the thing worked. But it is, like, as you said, it's completely opaque, right? Because it's all just layers of markup and weird reactive libraries and stuff. Whereas back in the old days, right, you can imagine, even though the UIs look crummy, 10, 15 years ago, when you view source, one, the markup was fairly straightforward. You saw there was a div or a menu element that's hidden or something, right? And the second one is the JavaScript is probably straightforward. You could probably just do a jQuery event and just say, open this thing, and then, type in this thing, and then press this button. But now, like, in order to do this sort of scripting on just an automation on an existing modern web page, I think it's like pretty impossible because everything is behind so many layers, right? And it's just like the view source is useless now.
Yeah, I mean, my daughter, who's now graduated from college, but when she was around 10, she was involved in this online site. It was actually really weirdly charming in a way. You would create all these virtual animals and take care of them. And I remember
Neopets?
Neopets was a sort of like that thing.
So it was one of these things, right?
But it was like that. This one tended to be this one tended to have people making up really exotic animals, and she got very involved in an anti-euthanasia movement, which I thought was very socially responsible, until I realized it was anti-euthanasia for animals that were virtual.
Interesting. Right,
I was like, what does that mean? But
so learning philosophy, in the computing. Yeah, keep going. This is really interesting.
Yeah. but yeah, I mean, when she was 10 years old, she did precisely that to build her own site.
Hmm.
Cut and paste bits and pieces of stuff to reorganize her page with the with the with the various dragons and classical Greek monsters that she had mashed up from other things. Um, and you could do that. You could do that as a 10-year-old without any particular knowledge of programming.
Yeah,
Uh,
yeah. I mean, there was like the really flowering, days, and yeah, back in the GeoCities days and back in the the Web 1.0 days where people just had just terrible JavaScript that they would copy from each other or just HTML and stuff, right? And it was great in that, it was such a flowering of creativity. And the glitch folks, right, who kind of spun
yeah,
off of Fog Creek, they're trying to bring that back, right? But it is their own system, right? You have to go
yeah,
into glitch, and they're trying to, and also obviously for a long time Scratch and these other systems, they have their own communities, right? I mean, Scratch has been going on for over a decade now, and it has a pretty devoted community of young people on it. And but still, there are these. It's not the open web, right? It's its own thing, right?
yeah. Yeah, although, I mean, I need to look at Glitch more, but what I've read of Glitch and what I've seen of it, I'm very impressed with what they're doing.
Yeah, yeah. I mean, because they're using regular web technologies, and I think they're it's just my impression. Let me just see. My impression is that it's a it's a web IDE, and it just runs Node.js, so it has all the libraries installed, and it has Node.js server component, and then it has all the whatever libraries for your front end. So the goal of Glitch, which is really admirable, is that it just tries to remove all this cruft around setting up your web development environment. It's like, how do you set up a modern React app, right? It's like you have to install this stuff and then install Node, install all this stuff. And the hope is, if it works, you just go in their web ID and you select, I want React version whatever, and then you can start building an app or
Yeah.
or such. So yeah.
Yeah. So I guess one of the questions I have is how, glitch is one kind of a way forward. Um, or maybe a way backwards. I don't know. I
Right.
mean,
And
it's
it's still
really,
the existing paradigms, right? It's just trying to make the existing
yeah,
complex web paradigm simpler, but it's still it's not anything fundamentally different.
yeah. So I do wonder, I mean, because the other thing that people have mentioned to me in the context of that article that I wrote, is the notion of programming as programmer as plumber versus programmer as, researcher or algorithm designer seems to have resonated with a lot of people.
Yeah, yeah. Let's
Um,
go into that. Yeah. So you want to talk about
well,
the two sides in that way?
well, I'm interested in what you think as somebody who teaches probably on both sides of that.
Yeah.
But,
I mean, I guess my
uh,
interpretation of what you just said, and I'm reading through the article again, um, and trying to read in real time. Yeah, I mean, it's interesting. So this is an interesting thing. I think this is a life. It's an ever, especially in higher education, right? So if you're in a formal university, especially the kind of more elite institutions, right? They kind of pride themselves on, I guess, teaching programmers as algorithmic and mathy people, right? So I guess
yeah,
the one side is, you're learning something like Scheme or Lisp, or even if you're learning in Python or Java and stuff, the focus of the computer science courses, right? They use programming, but the focus is on algorithms and, maybe design patterns for systems and stuff. And and a lot of it is trying to, it's developing these algorithmic thinking skills, right? Computational thinking, algorithmic thinking skills. But then when people go out in the working world, I mean, this is very well documented, right? Like if you're getting a job as out of your bachelor's as a software engineer, even out of your master's, you're in such a different world where you are a programmer as plumber for the most part. You are thrown into a giant code base, and your code base in your company uses all internal company APIs that have been developed by your colleagues, and then it also uses external APIs, and it has a bunch of tests, and it has a bunch of DevOpsy tendrils everywhere, and your job is to go in and try to pry apart part of it and then extend it with a new feature, right? And then when you make a new feature, most of your code is calling the right APIs, right? Calling a user interface API, a web service API, whatever to draw your widgets on the screen, whatever to test. And then, the big disconnect that students get, and one of their complaints about academic computer science programs is, you taught us all this stuff about dynamic programming and algorithms and linked lists and stuff, and then in our job, we're basically doing plumbing. So, and the argument from the other side is that, these fundamentals are good. It's like studying physics or math, right? They're good for extending your mind, trying hard things, thinking rigorously. And then when you go to a job, if you have thought rigorously and systematically, you can pick up all of the, technologies they use, because that's all on the job training, right? So I can see it from both sides, right?
Well, it is interesting. It's certainly true that one of the things that, at O'Reilly we hear from, we hear from the employers is we hire all these really smart people out of school, and they don't know all the stuff that they need to know. They don't know how to use Git.
That's right. That's right.
Which, I don't really know how to use. I'm not sure if anybody really knows how to use Git, but they don't know how to. They don't know how to work. They don't know how to work on teams. And it's also interesting that I've seen, going back to, when I was in graduate school, I was the oldest kid in my family. I came back on some vacation, and my youngest brother I went to a high-end prestigious school, and my other brother, my youngest brother, was a really smart guy, but really hated standing out at anything. Mm-hmm. So he went to sort of the middle tier of the state college system in mm-hmm. Connecticut, and he was a computer science major. And I happened to see his, well, I don't know what you'd call it now officially, report card, whatever, right. Transcript, and it was like, you're doing well, but I don't recognize any of these courses. Mm-hmm. It was like, database programming with FileMaker.
Right. It's a lot more vocational, right? It's a lot more specific technologies. Yeah.
Yeah, it was very vocational, and I wasn't a CS major. I was an EE, but I know what the CS majors did.
Right. And especially back then, it was way more theoretical. It was more algorithms and proofs, and it was less programming, and probably
yeah. So, and it's interesting that I ended up in a job where I'm writing about this stuff and thinking big ideas about this stuff, and he's in a job where he's doing quite well, but doing the supplied stuff.
Right. Yeah, and and it's interesting. This all fits in with all these coding boot camps too, right? So one of the personas for people who go to coding boot camps is that they majored in something that maybe STEM, maybe not, right? So, somebody is a physics major, right? And then they went to physics graduate school, and they're like, I really don't want to be an academic physicist, and I want to be a data scientist now, or an app developer, so that I'm going to take this really intensive boot camp. And I already, went through a rigorous physics education. I know how to do school. It's just I don't have these skills in Git or Python notebook, Jupyter notebooks, or pandas or R or whatever. So I'm going to take a boot camp, really intensely learn these skills, and then go interview for these data science jobs and do pretty well, probably, because I filled in those gaps, right? These technical gaps.
Yeah, no, that's an interesting thing. And yeah, the people I know who have gone through the boot camps and have done the best are the people who have already had a fairly substantial education.
Right.
It's actually interesting. I probably shouldn't name them, but I was talking to somebody from from the carpentries.
Right.
A number of years, data carpentry, in fact, but a couple of years ago, and I said, so wait a minute, you're going out and you're teaching programming to physicists? Haven't these guys all known how to? I did say guys. I suppose that is still very gendered. But,
right.
But haven't these guys been programming since they were 5? And the answer was yeah. They've been programming since they were 5, and they haven't learned anything about about it since then either.
Hmm.
So, um, so they still know nothing about software engineering. Their code looks like they were writing in BASIC.
Yep.
Uh, and it is interesting. There is this need to get both sides of that together. Um,
Yeah, and I feel like there are some, like University of Waterloo, for example, right? Their software engineering program is very widely known, right? They have a combination of, very, traditional computer science courses and then like applied software engineering courses. And then they also have this co-op program where the students go and intern like a lot, right? So that this sort of, I mean, Waterloo sort of stands out in my mind as this training kind of these software engineers in a traditional 4-year college. And they have this really intensive program where they combine the computer science training with a lot of practical software engineering courses and the co-op internship program. So like by the time these students graduate, they've had, I don't know, like 4, 5, 6 different small internships at different companies. And the internships are really where you learn that hands-on stuff, right? And
yeah,
so, maybe not all that needs to be learned in the classroom. And then, for someone like me who's come up in research, a lot of the practical knowledge I learned was through doing research projects, right? You have to implement, that's
yeah,
how I learned C. That's how I learned about compilers. Like just like it wasn't like taking classes. It was like I needed to build, some extension to some compiler for a project. And you would ask the grad students around you. And this sort of informal learning really interests me, right? And, I think it dovetails really well with a lot of the O'Reilly stuff, right? So from online tutorials, from books, from communities of people, something that's not just here's a 4-year college, here's a formal class where 10 weeks or 15 weeks and you get a grade, right? Like that's just such a small part of the total space of stuff you could learn from.
yeah. But I mean, that gets back to what you started with. I mean, Kernahan and the gang at Bell Labs developing Unix and sharing code and ideas with people who were just down the hall.
Yeah. Yeah,
and
this online community or real life community, right? It's hard to be. And one more anecdote about that you might relate to is that they had this Unix room, right? So they had this room where all their computers were, where all the Unix folks were gathered, right? So because back then, these computers were big, right? These were PDP-11s and that. I mean, they weren't huge compared to the older ones, but it was that physical room is cool in the sense of that gave people a congregating place, right? I remember when I was at MIT, they had these Athena clusters, right? All these computer clusters, and I was in college at the tail end of people using desktop computers in clusters, right? Because afterward, now when you visit MIT, a lot of those clusters, they got rid of the computers and it's just workspace because everyone has their laptops. So there was a charm about having everyone be there on the crappy Sun computers or whatever computers they had back then, because all the software was on those computers. And since they all congregated there, I remember the TAs and the tutors and other people would all just hang out there and help. And like that physical room and those kinds of interactions are they seem really hard to replicate online, right? So I just want to know your thoughts about that sort of community aspect.
Oh, that's interesting because you do sort of get some of that on social on GitHub with the idea of social coding, but it's not that I don't know that not really that much.
Yeah, and there's a lot of noise online too.
Trying to think if you could do could you do something that was really like Facebook for coding?
Yeah. Without all the noise too. I mean, there's also usual noise of online interactions, right? And even some of these MOOCs, I haven't seen them in detail, but some of these MOOCs in their heyday, when they were running the MOOCs synchronously, right? So right now the MOOCs are just self-serve, right? Most of them are just you go on whenever. But when they're running them synchronously, there was a charm because the forums are very active, right? Because everyone was in week 1, everyone's in week 2, and they released the next week. And everyone kind of gathered around these forums, and then they formed Facebook groups also, and that was cool.
Well, and in some cases, in-person groups.
That's right.
Too.
That's right. And then person, I was about to mention that. Like that is, that sort of impromptu rallying around a certain thing. Like Andrew Ng is going to release the next lecture. Let's all watch it and then try to work through the problems. Like either online or in real life. Like that's a sort of vibe. Just thinking as an educator as well, right? Like. That's the sort of vibe that we could hopefully create in schools. And, even out of school, right? If you have meetups, right? These user groups and meetups, like that's something about that interests me because, although of course you can learn everything in theory on your own, right? It's just a lot harder to, right? Without that community.
Yeah, that as far as that, yeah, that for education, community is really important. And I mean, this is maybe not appropriate to this particular conversation, but what I was, have always thought about college is that it's actually, not so much about the faculty or the program. It's about the students that you're going to get to, the students that you're going to get to hang out with for 4 years.
Totally. I mean, we can talk about that too. I mean, it's a free for all, but yeah, totally. I mean, I think that everyone would, everyone who's been in that setting would probably agree that, one of these things is fostering that sort of community amongst the students, right? And as faculty, how do we foster that, and also how do we get out of the way, right? How do you provide the right space, but also not too much oversight so that it, I mean, like just with a lot of MIT history, right, of just like having these, gray spaces, right? These spaces where, people are doing probably borderline illegal things, right? But if the administrators turn the other way, these amazing hacks and innovations come about because, not just in computing, but in a lot of engineering, right? And now, modern colleges are a lot more afraid of lawsuits and, bad press and litigation and stuff. So they, one story was, MIT they shut down some of the dorms with a lot of, history behind them because they were, I think there were lawsuits or there were cases of, bad or illegal behaviors and such. So they wanted to really clamp down. And, on one hand, of course, from a certain perspective, I could see how that's justified, right? But on the other hand, a lot of the students and alumni really kind of protested against because this is like our institutional culture and memory, right? Like of living in the dorm and doing this stuff. And, some of the stuff might have been kind of sketchy, but, we benefited from that. And a lot of the stuff, probably when you're young, you don't have to tell specific stories, but, this sort of countercultural stuff is, I don't know how we're going to, what place it has today and where we can find that. Right. So.
Well, it's funny because I have thought about how that's changed. And, I mean, some of the stories that are shareable are, I mean, in high school, I had a full beard, so I could go down to, I could go down to Yale and walk into their computer science building and sit down at a public terminal and nobody would question my right to be there.
Yeah.
And I got invited some summer to, one of these programs that I'm sure they still do where they invite smart people to come down to, the campus and listen to professors. And there's one engineering professor, I forget what he was talking about, but I was talking to him afterwards, and I think he might have been talking about APL. And then I said, it'd be cool to play with that. And he said, well, here's my username and password.
Yeah, just go do it. Yeah.
It's like, I mean, he was really sort of a department grand old man, but I think that even as a full professor with a chair, I think that would probably get you fired today.
Right. Yeah.
And that's something which I think in a lot of areas that we're missing. There's a kind of experimentation and free for all that's really creative. I mean, not that long ago, I read an article, I think it was in the New Yorker, about the invention of chemotherapy.
Interesting.
And the guys who did that were just cowboys. Mm-hmm. I mean, they were insane. They were out of their mind, and there was no way at all that if they lived that if they were working now, they would have been allowed to do any of the stuff that they were doing to their patients.
Yeah. I mean, this goes. I mean, this is a whole other issue, right? Of where does that line get drawn, right? I mean, especially medical ethics, right? That's like even more like literally life and death, right? That there is this gray area, right? Whether it's in computing or in health and stuff, and these great inventions could be made, but then it's like, do we want to actually formally endorse that, right? It's hard.
And yeah, I mean, this is quite far afield, but there was like, oh, well, gee, this drug didn't work, that drug didn't work. What if we try to give the patient both drugs at the same
Yeah,
time? They're going to die anyway, And it
yeah,
was
yeah,
like, really, the thinking was just about that crass. And if they hadn't done that, we would basically not have we would basically not be able to treat cancer at all.
yeah, yeah.
So, uh, so yeah, there is. How do you foster that kind of creativity? The kind of creativity that you had in the early web. I mean, it would be really interesting to see someone really try to build, not GitHub, but the Facebook for coding, where people could feel like they were in a virtual group and say, hey, I just wrote this strange thing. Anybody want to play? Anybody want to play with it? Um, I don't think that's impossible. I think one of the issues that we probably would have to deal with sooner rather than later is basically the issues that are showing up in the other aspects of the internet. I mean, I'm always sort of amazed that people like um, that people think that the problems we have on Facebook and Twitter and the social media today are new, because if you were on Usenet in the 80s, all of this was there.
Yeah, yeah, yeah. Yeah, it wasn't like it
Uh,
was this utopian place, right? I mean, in a way, it's interesting that it's just more in the public consciousness because more people are engaging online in discussions, right? And back then it was very select niche groups of people, but then all the same politics and trolling and drama and stuff ensues whenever you have a bunch of people distributed, with opinions on stuff and colliding in these ways.
yeah, but I do wonder if we were to create the Facebook for code, um, a really good sharing and discussion platform. And it's conceivable that Stack Overflow might be that already. Actually, if you combine Stack Overflow and Git, which, given that they're all owned by the same organization, um, is very plausible.
Yeah,
Um, but
it's interesting. Yeah, and I mean, I guess the other part of that, yeah, I had a I had a thought that just escaped, but yeah. So now, nowadays, there are, on sites like Hacker News and maybe on Reddit, people do show and tells, right? It's like, oh, I made
yeah,
this new app and get feedback, and then in the earlier days of Hacker News, I remembered it being more about the spirit, right? But now it's become so
yeah,
entrepreneurial, where people are like, how are you going to make money? People are like this sort of creating software spirit, even making web apps, let's say, as an example, so much of it has been driven by entrepreneurialism of like, oh, I want to make an app to like start a small business or something from it. And there are fewer people, I think, maybe that could kind of bring this discussion back to the beginning, is that there are fewer people experimenting with, I'm going to make a new kind of, visual programming environment. And it's people are like, oh, is that going to be a business? And they're like, no, it's just my exploration, right? And how do we somehow foster that? Because I think we're done enough to foster entrepreneurialism. I mean, like there's so much infrastructure and attention around how you're going to start a software business, right? I think that's fairly well understood.
yeah.
But like, how are you going to develop the next kind of programming language that doesn't have a business platform, right? As you probably know, things like Lighttable and Eve and those sorts of programming language environment projects that try to spin out as startups, it just inevitably doesn't make it because there's not really that direct of a market for a next generation thing. So it's a hard thing.
I mean, it is hard. I'm disappointed that Lighttable didn't make it. Somebody observed a couple of years ago that it's almost inconceivable that a programming language could succeed that was not an open source project.
Yeah.
Which, um, I mean, outside, I suppose, of a walled garden environment. So, maybe C Sharp.
Right.
It
Right.
actually is C Sharp open source these days. I
I don't
wouldn't be
know.
surprised if it
Maybe
is.
the Linux. Yeah, but I mean, yeah, that's an example of it's obviously driven by a big company ecosystem. Right? It's not an independent project. I mean, there was this Dark project. I don't know if Dark is open source or not, but they're another one. They're the latest in the software startups that are trying to do a programming language and environment and such. So Jonathan Edwards keeps track of a lot of this stuff. I just saw Jonathan last week, but and he's really trying to push these sort of independent researchers to try to innovate that. So I guess in the last minutes we have it remain, like how in your ideal world, how would you build the right conditions for making these innovations? Right? Does it have to be another Bell Labs, or does it have to be some really rich billionaire investing? How would this happen?
That's a really good question. I mean, we don't really have Bell Labs anymore. We do have Google, although Google seems to be putting more into. Well, it's an interesting question. Google seems to be putting a lot of money into these very expensive, showy moonshots. And I'm thankful to them for doing that, but I don't know if the moonshots are what we need. I mean, the transistor was just this weird thing that nobody could figure out. It's like we made this thing. We don't really know what it's good for. But it does something.
Yeah, and even the moonshots that Google are going, or other companies are going for, are there is a vision behind it, right? It's like we want to launch balloons, or we want to have a direct application, right? So because it's still a fairly kind of corporate minded thing, that of course that's how it works. Or whereas this sort of basic research lab that had such a long time horizon is so unique, and how do you? I don't know how you foster that, right? That within universities, it's possible to a certain degree, but universities lack that scale, right? That research groups in universities can make prototypes and do studies, but we can't, make the next Unix, right? At that scale.
No, you can't, and you still have to get grants and all of that.
Right.
When I talk to people who are in the process of getting grant applications written, I'm very happy that I didn't go into academia. But, universities are good for that. I don't know. I mean, I think Google's idea behind the 20% project was to foster some of that, but I mean, even back in the heyday of the 20% project, most people I knew at Google said, nah, it doesn't really work that way.
Yeah. I would agree. I mean, I worked there full time for a bit, and I was also an intern there, and it's like, I think it's, maybe in the very early days, some of these projects really spun off, but you do have to justify your time, right? It's like, oh, I'm joining a 20% project to work on this new feature that extends blah, 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 right? Or, something else that, and it's not, it's, and also it's not that much time either, right? To form a sustainable thing. So.
Yeah. I mean, one of the things that worries me, and maybe this is because I'm older, but it's that, there's a sense in which innovation actually has become harder because the easy things have done. Well, I mean, a couple of examples. One was that, I'm very proud of having done this, but when I was in high school, I invented hash tables and linked lists.
Awesome.
And well, I mean, I think that's awesome, but I also bet that there are probably a few thousand high school students from the early 70s who, I'm
discovered
trying to do this. I get sort of works like that.
Yeah.
and 5 years later, you're in college, and it's like, oh yeah, that's an algorithm.
Yeah.
I mean, the other thing is, but I don't know that there are easy wins like that left. I mean, the other thing is that one of my hobbies is ham radio, and if I point my laptop in a different direction, you'll see you can see a $3,000 radio. But that $3,000, when I was in high school, was sort of the closing days of being able to build your own radio. Now, if I were to take that apart, it would be, a bunch of very fine-pitched surface mount technology that actually I've known a few insane people who say, "Oh yeah, building that stuff is easy," but it's like my eyes aren't that good. I can barely even see the leads on some of them. And yeah, I mean, you can make a simple crystal radio like I made when I was probably 10 years old just as easily now as you could, but it doesn't mean the same thing. Oh, your audio just disappeared.
Yeah. So even going farther afield, maybe maybe we should start looking into a new domain for this sort of creativity, right? So what is the next domain that was like the open web was, 15 years ago, that was like ham radios and algorithms 20, 30 years ago, maybe this is in, I don't even know, right? Like, some kind of new materials or crafts or some kind of thing where it's so open-ended that, that hobbyists, right? Hobbyists and kids can actually make interesting innovations. And I agree with you that in computing and electronics and cars or whatever, it's not possible anymore because things are so saturated. But it has nothing to do with programming, but it's like, what is that? Maybe there was that next thing that gets people as excited as they were. I grew up in the days of the early web, and that got my generation really excited, right? And then your generation got excited with, other parts of programming and hardware and stuff. And like, what is that thing for this generation, right? And,
Well, I've thought for a long time that thing, and this has not panned out, but I think it still could. That thing might be biology.
Mm-hmm, mm-hmm.
I mean, I've told a lot of people that, when I was, in 1975, when I was I was a sophomore, junior in college, something like that. A guy I knew in the dorms built his own computer around, I don't remember what chip it was. I think the Z80 came out later, but something like that. Synthetic biology has seemed to me to be on a similar trajectory, although it also seems to be a little bit stalled. And I'm not sure what it takes to get it over the hump. But it was really interesting at one foo camp, at one sci-foo. I talked to a number of people who I had gotten invited, who were synthetic biologists, and said, "So, when are we going to see this in the high school programs?"
Yeah.
And they said, "Oh, gee, this is still a little bit hairy, probably not for a few years." And I got, came back, and my daughter got her summer reading packet for AP Bio, and it's like, "Oh, cool! We're making we're making E. coli that glows blue." So I sent those guys email and say, "Hey, when is this going to get in the public schools? It's there already." But what I haven't seen there is the ability to go beyond, the E. coli that smells like bananas, or the E. coli that smells
the
blue,
very
or a couple
canned
of other really
experiments
simple
that you
things.
do in class, right? They, can it get to the stage of, these early Arduinos or these early, Lego Mindstorms things where you can actually put stuff together and recombine stuff in non-trivial ways? And, I don't know anything about synthetic biology, but it seems hard, right? It seems like it takes a lot of investment. And how do you make the equivalent of Arduinos for that, right? That low price, easily accessible, safe, for that world.
Yeah, I don't know. And so obviously there's some hurdles that have to be gotten over, but I think that's where we'll see it. I'm not terribly worried about, some high school kid creating a super virus.
Right.
And I do know that people like Drew Endy, who is, he's at Stanford, has been working for a long time on the idea of standardized biological parts, which, in radio is what we always had. You got a resistor, it did what a resistor did, and you could read a spec sheet on it if you really wanted to. And Drew's argument has been, this is what we need for biology. This is a gene that will do this thing if you put it in that other thing.
It's a basis for engineering, right? It's a basis for doing engineering and by extension programming, right? Which is a form of engineering. So,
it really is turning biology from research into engineering.
Do you have a good link for that? For that idea, I'm gonna try to find a link for this. Do you remember the term they used?
Oh, what is the term that they use? Because he does have let me.
I'm just adding
But
tabs.
look at BioBricks. That's
BioBricks.
yeah, BioBricks.
Oh, nice. BioBricks. Got it. Foundation. So this is out of the Bay Area, right?
Yeah,
Interesting. BioBricks Foundation, right? Huh. Synthetic biology. Okay, I will.
yeah. But another thing to look at. Oh, gee. Gee, I can email it to you. There's another
Okay.
link that's on the tip of my tongue, but not coming out. But
Yeah, I mean this is really cool. I mean, just kind of wrapping up here, kind of coming on the hour. I mean, what do you think? What now, right? So you wrote this article, and in your work, is this trying? What lever do you want to pull? I guess with this, besides getting the information out there and echoing that call.
um, well, actually, this is another long free flowing discussion.
Sure.
But one thing that I wrote some, I actually, one thing that I wrote some notes on, and I'm sort of scared to go any further because it's stuff I don't know about. But I was at a biology conference, I forget the name of it, a few years ago, where somebody from Microsoft was doing some serious work on basically IDEs for DNA.
Wow. Interesting.
But he said that there are hints in DNA that DNA is a programming language.
Mm-hmm.
We don't know how it works. There are hints that there are control structures in DNA that don't map onto anything that we understand
Wow.
that we understand from our knowledge of programming. And so what I would really like to get to is like, okay, we have languages with if statements and loops. And if you're a functional programmer, we have languages with recursion and map, which save you some of the bookkeeping. But can we really break this thing open and think about, if we had completely different control structures,
Mm-hmm.
what would they be?
Mm-hmm.
If we had, what would they be? I mean, talk that again, this is just walking through the Yale campus once. I saw I saw a poster for a talk about about non-algorithmic programming languages, and it made it clear that Excel, this might have even been pre-Excel. What was that he was talking about languages like Excel. And it's interesting because if you want to talk about democratization of programming, you can do amazingly sophisticated things in Excel.
Yeah.
But almost nobody who uses it calls it programming. In fact, most programmers hate it.
Yeah. That's an age-old, straw. Yeah, that's the age-old thing. Yeah.
I tell people, hey, if I have to do anything with Excel, I suck it into Python and do it there.
Right. Yeah, such a different frontier, and I don't know. I mean, I don't know how we can foster this sort of an environment. I mean, Alan Kay tried, recently, right, and then they ran out of funding, right? That they really tried to sustain the stuff with corporate funding and some philanthropy and stuff for years, and then now Brett Victor has his Dynamic Land thing, and I think they're trying to get private funding for that. But these sorts of organizations that do these things they're hard to sustain, right? I mean, even Bell Labs doesn't last forever, right? But it lasted pretty long, but not forever.
Yeah, they are hard to sustain. I mean, I do wonder, the hints that Microsoft was doing some really interesting things with DNA that might have some implications for programming. That's incredibly suggestive. But,
Yeah, so Microsoft Research has had, they probably have the most critical mass in computing nowadays. And maybe other organizations can step up in this way. So, yeah, this is great. I mean, we're coming up on an hour. I mean, any kind of last minute thoughts or closing thing? I mean, we covered a lot of ground, which is cool. I mean, this is the fun thing about these podcasts that we started with one thing and I just kept opening tabs and we'll have a bunch of show notes.
Okay, yeah. Well, gee, yeah. No, this has been great. I've really enjoyed talking. I'd be glad to do it again, and be glad to do it for, have you interviewed for O'Reilly for something that we do.
Sure, sure. Yeah, I'm happy to talk. I mean, whatever you feel like I have some kind of a qualification to talk about. Talking is the easy part, right? Actually doing the stuff is actually writing the stuff and programming and building the organization system is the harder part, right? This is, I can always come on and talk.
Okay. Yeah.
All right, thanks, Mike. Okay, we'll go offline. We can chat for a bit more. This is great.